All right, let's be real. Technical interviews, they can be a total nightmare, right? Especially when they start throwing spring rest questions at you. But what if I told you that you could get the absolute key concepts down in like the next 5 minutes? That's what we're gonna do. This is your crash course to absolutely nail that interview. Okay, here's our game plan. We'll start with the controller, then talk about routing requests, handling data, building really solid APIs, and finally, making sure they last for the long haul. Let's jump right in. All right, section 1, meet the controller. This thing is literally the brains of your entire API operation. It's the first point of contact for every single request that comes in. Okay, this is a classic interview question, so listen up. What's the difference between @controller and @REST controller? Think of it like this. @controller's kinda old school. It's for traditional web apps where you need to return a whole web page, an HTML view. It's like a tour guide showing you a finished painting. But @REST controller, that's what we use for modern APIs. It doesn't care about views. It just gives you the raw data, usually JSON. It's basically a shortcut for @controller and @response_body combined, which is exactly what you want for a REST API. So how do you remember this under pressure? Simple. Just think API versus view. @REST controller is for the API, @controller is for the view. Done. Okay, section 2. Let's talk about routing. How does your application know where a request is supposed to go? Well, it's like the API's GPS system, and it's all about mapping. So you've got @request mapping, which is kind of the old do-it-all tool. It can handle any HTTP method you throw it at it. It's a Swiss Army knife. But here's the thing interviewers look for: using the right tool for the job. That's where @get mapping and @post mapping come in. They are specific. They shout, hey, this method only handles gets. It makes your code so much cleaner and easier to read. It's a huge best practice. The memory hook here, generic versus specific. Always go for specific when you can. All right, what about grabbing data from the URL itself? You've got two main players, @path variable and @request parameter. @path variable pulls data from the path. So for a URL like user/123, that 123 is a path variable. It's part of the core address. It's required. Think of it like a house number. You can't find the house without it. @request parameter is different. It's the stuff after the question mark, like users/role equals admin. This is for optional stuff like filtering or sorting. It's like asking the mailman to only deliver packages on Tuesdays. It's an extra instruction, not part of the main address. So the takeaway is easy. Path versus query. Path is for required IDs. Query is for optional filters. Section 3. Okay, we know how to route the request. Now let's talk about the good stuff, the actual data payload, the ins and outs of your API. This one is super straightforward. You just have to think about the direction of the data. @request_body is for data coming in. A client sends you some JSON, and this annotation magically converts that text into a Java object for you. No manual parsing, it's awesome. Then you have @response_body for data going out. You have a Java object and you want to send it back as JSON? This annotation handles it. And remember that pro tip? @REST controller does the @response_body part for you automatically, so you usually don't even have to type it. Your memory hook? You guessed it, in versus out. Request body in, response body out. Simple. All right, section 4. Now we move from the basics to what makes an API truly professional. This is the stuff that separates the junior devs from the senior ones, building robust APIs that don't fall over. So let's think about the real world for a second. What happens when things go wrong? Because they always do. A user sends you garbage data, the database goes down. What then? Does your whole app just explode? Hopefully not. You have an awesome toolkit for this in Spring. First, for handling unexpected errors, you use @controller advice. Think of it like a global error department for your entire API. Instead of littering every single method with try-catch blocks, you have one central place that catches exceptions and sends back a nice, clean error message. It's a lifesaver. Then, to stop bad data before it even causes a problem, you use the @valid annotation on your incoming data. You can add rules like @notnull or @size to your Java objects, and Spring will automatically check them. If the data is bad, it gets rejected right at the entrance. So for the interview, remember these two: global errors and input checks. Okay, another big league problem. Your API needs to return a list of items, but there are a million of them in the database. What do? You can't just send all million records at once. You'd literally crash the server, the network, and the user's browser. It would be a total disaster.
The solution is to not give them everything at once. You use pagination. Spring has this amazing pageable object that lets you serve up the data in small, digestible chunks, or pages, like Google search results. And while you're at it, why not let the users sort and filter that data? That's where things like the sort object and JPA specifications come in. This shows an interviewer that you're thinking about performance and scalability, which is huge.
Just remember these two phrases: page chunks and order plus filter.
And for our final section, number 5, let's talk about the long game. How do you build an API that doesn't become a mess in 6 months? This is all about future-proofing.
Content negotiation sounds super complicated, but it's really not. All it means is that your API is flexible about the format of the data it sends back. Maybe one app that uses your API wants JSON, but another, older app needs XML. No problem. The client just puts a little note in the accept header saying, "I'd like JSON, please," and Spring takes care of the rest. It's that easy. The memory hook, format choice. The client gets to choose the format. And the big one, versioning. Look, your API is going to change. You're going to have to make updates that break old versions. So how do you manage that? The absolute most common way you'll see is just putting the version right in the URL. You've all seen it, /v1/users, /v2/products. It's super clear, everyone gets it. Now, are there other ways? Yep. Some people will argue about which one is the most restful, but honestly, URI versioning is king in the real world. It just works. So there you have it. We've blasted through all the key tools. But here's the final thought I want to leave you with. Knowing what @Rust Controller does is one thing. The real challenge, the thing that makes you a great engineer, isn't just memorizing these tools. It's understanding how to use them together to design something that's elegant, strong, and built to last. So the real question for you is, how are you going to build an API that lasts?